Everybody knows that August is a slow news month, right? Not this month, not for astronomy. We had so much that I actually had to cut down. So there's a bunch of cool news that I'm not going to get to tonight, okay? So let me just go through what I do have relatively quickly. My top story, or I guess I should say my top non-story, is from curious to spurious. I am talking about something I noticed on Saturday, August 27th, an interesting SETI candidate in Hercules. This was on I noticed this on social media, and there was a comment that there was a signal in the direction of the star HD 164595, and that star is known to have an extrasolar planet around it, okay? And it came from the Ratan 600 radio telescope in some unpronounceable place in Russia, okay? And so here is the signal that was published, that you can see the pink line is the actual signal, and the green line is a fit for a point source located in the position of HD 164595. So the conclusion of this article was not that, oh my God, we found aliens, but it was rather softly stated, the signal is interesting and merits further scrutiny. However, once the internet gets hold of it, what do we get? We get this. SETI is investigating a possible extraterrestrial signal from deep space, a strong signal that may originate from a sun-like star. Aliens? Sunlight being verified by SETI. Yeah, okay, so, and it got off into all sorts of interesting conversations about extraterrestrial civilizations that have built a Dyson sphere around their star and are capturing all the light from that star, and for some reason then beaming all that energy right back out into space. I'm not sure exactly why you would do that. I got home Monday night and my wife started telling me about an astronomy discovery. My friends on Facebook, my high school friends who I'm friends with on Facebook, they always start to tag me whenever they see something interesting, say, Frank, explain, explain. So I had to kick in, and I put up something a little less glamorous that said something like, a signal worth investigating, but it's probably not aliens. And I wrote about 10 or 12 paragraphs about it on my Facebook page so that I could explain to people, well, you know, here's what's really going on. Meanwhile, the folks who are actually going to follow up this investigation were doing the follow-up. This is the SETI folks here in the United States, and this is their webpage that they put up to talk about this solar system 94 light years away as a possible candidate. Well, they immediately started turning their telescopes onto this star, looking for something, and they had 10 times better sensitivity, and they didn't find anything. So they were pretty doubtful. And then 2 days later, on August 31st, a press release came out from the Russian news agency TASS that said an additional check showed that it was emanating from a Soviet military satellite which had not been entered into any of the catalogs. Now, we look at this and we say, oh, everyone's making a big fuss over nothing. But this is how science is done, okay? Astronomers who find something interesting and don't have enough sensitivity to really check it out tell others about it, and then those go in and check it and see, and they cross-check it. It has to be observed by multiple people using multiple instruments in order for people to really take it seriously. So the science was done right because they said, look, we're not claiming extraterrestrials here. We're just saying this is interesting. Somebody please follow up. And the follow-up showed you, oh, sorry, it isn't actually interesting, okay? However, in the internet age, we have a moral to go by here. And the moral of the story is scientists must strive not to cry wolf because that's the job of the internet, okay? All right, our second story, we're going to do some interplanetary mission updates. The first update comes from the Juno mission to Jupiter. And if you were here in July, I told you about the Juno mission inserting itself into orbit around Jupiter, the beginning of the Juno mission, and the fact that it's going to go into this very tight orbit and go very far away, and it's going to sample the full range of the magnetic field. Well, It's on a very long orbit initially, and it just got back for its first pass. So in July 2016, it does the insertion. It's going to do 2 orbits with a 53.5-day period, and then it's going to follow that by 35 orbits with a 14-day period. So on August 27th, it made its first flyby of Jupiter, and this image right here is as it's approaching for its first flyby, okay? And what we're going to get, at least in the visible light images, come from a camera called Juno Cam. And Juno Cam is not a science camera, all right? I want to lessen your expectations here because it is an outreach camera. It's just a 2 megapixel. It's like a webcam sitting on the science satellite, okay? It's going to get some cool pictures, but it's not a real science, deep science camera. Most of the science going to be done from Juno is on the atmosphere and the magnetosphere. It's going to have some ultraviolet imaging and some infrared imaging, and it's going to look at the aurora and such. But the visible light images from Juno, they aren't the highlight. They aren't the science goal of the mission. Okay, but it did get some cool pictures because we have not studied the poles of Jupiter very much. The last time we saw the North Pole of Jupiter was in 1974. Well, now we have these images, okay? So this is Jupiter's North Pole. All right, let me just go back to this one here. You can see that most of Jupiter is this banded structure, okay? That's the stuff we're used to. If we go look at the North Pole, however, you can start to see, especially in this enhanced image, that you've got all sorts of storminess going on in here. You do not have that banded structure, all right? And what's really cool, not just to see the North Pole, but they got this gorgeous picture of Jupiter's South Pole. All right, now can you see the amazing number of storms? And there's still a little bit of bandedness to the structure, but there's a lot more turbulence going on. There's slower speeds down here, okay, in the motion of it. And so you can see that you've got a different pattern on Jupiter at the poles than you do in that standard banded structure that runs around most of the planet. So this is really cool because we've really not seen the poles of Jupiter, and we will get more of these as the mission continues, okay? But the next pass won't be until October. At that time, they're going to do a burn to go into the 14-day orbit. So Juno has gone into its serious science mode. All right, it's getting great observations, and we look forward to more cool pictures, but really a lot more serious science about the atmosphere to come. Our second mission update is about Rosetta, the Rosetta mission, and the lander Philae. Now, if you remember, how many of you were coming to the public lecture series back in 2014? Okay? Do you remember November 2014? Because that's when we had a particular event. Now, let me just go through a little bit of this. Okay, so the Rosetta mission, its final goal was to comet 67P Churyumov-Gerasimenko. Okay? Or, just to make it easier, we like to call it Comet Rubber Ducky. Simply because of its shape. Now, so 67P was the target of it, okay? And the Rosetta main orbiter went into orbit around 67P. The Philae lander was released in November 2014 to land on, actually, what would be the head of the duck, okay? And it dropped on down for 7 hours, and when it hit, 2 harpoons were supposed to dig into the ice and hold it on. Well, the harpoons didn't go. So instead, Philae bounced. It bounced a kilometer upward, okay, relatively low gravity, it could jump really high, and actually did a second bounce and settled into an unknown region on the surface of the comet. It was obviously not pointed upward because it couldn't communicate. They got a few pictures from it, but they couldn't keep it alive, and the Philae lander was declared a loss in March of 2016. However, they knew where it was, and the Rosetta mission main orbiter kept orbiting around it and actually moved into closer and closer orbits as the mission continued, and they searched for it, and just a few days ago, they found it. Now, can you spot the Philae lander? Those of you who know where it is, yes. It's actually over there, all right? let me give you the blow up, okay? This is an amazing image, by the way. It's 5 centimeters per pixel, okay? 5 centimeters per pixel. Amazing stuff of the surface of a comet. Here is the Philae lander. They found it, okay? And you can see it's tipped over on its side, so of course it's not going to have good communication with the orbiter, all right? And here is a diagram, annotated diagram, to help you understand it. They're the legs of the lander. Huh? Where's the ice? The whole comet is ice and rock. Yes. But the surface of a comet is generally a sort of a tar-like substance, okay? Because the volatiles have gone away. All right. This comet only gets into about 1.2 astronomical units at its closest approach to the sun, but still the volatiles will go away. If you get inside 3 AU, then the volatiles on the surface will definitely go away. Okay. So it actually, one of the reasons why the Philae lander bounced was at the surface was harder than they expected it to be. Okay. Based on previous things, the deep impact, they expected a softer surface. All right, so this is the Philae lander here. Unfortunately, it's unrecoverable. All right. Call Bruce Willis. There you go. All right. So here's what I want to recap for you the Rosetta mission. Okay. It was launched in March of 2004. It had flybys of Earth 3 times. It flew by Mars once. It flew by 2 different asteroids. It arrived at 67P in August. The Philae landing was in November 2014. Rosetta stayed with 67P as it came up, approached the sun, went through perihelion last August, and 2 years later now, all right, it's still with it, and it's moved down to that very close orbit, and the mission is finally going to end this month. On September 30th, they're going to take the main orbiter and have that also land on the comet. Now, I say land in a general sense because, as one blog put it, it'll be more like a soft crash because it doesn't have the kind of landing gear that Philae was built with. So it will effectively crash into 67P at the time and will continue to orbit with 67P for the rest of history. All right, so we can look for some really cool images from the Rosetta mission the end of this month on September 30th, because as this main orbiter gets in close to the comet, it's got a lot more science instruments that it can take all sorts of cool readings and get a lot of interesting science as it comes in for a landing the end of this month. Okay? All right. I had to throw in one Hubble story. I'm sorry, Tom, I'm taking so long, but I had to throw in one Hubble story because the rest of the stuff was from elsewhere. And our final story tonight is Galaxy late bloomers. Okay, so Hubble released these 2 cool images this month of Pisces A and Pisces B, 2 dwarf galaxies. All right, and what's one of the really cool things was how these galaxies were discovered. So when I say galaxy, you probably think of something like the Whirlpool galaxy, sort of the standard big giant spiral galaxy, okay? But the Whirlpool galaxy is actually bigger than you think, because this is the visible light view. If we go into the radio and search for the hydrogen gas, the Whirlpool galaxy looks like that. There is a lot more hydrogen gas out there that we can see in radio than can be seen in the visible light of stars. So these dwarf galaxies here were actually found by radio searches looking for blobs of hydrogen. It was actually a survey of the Milky Way galaxy looking for hydrogen clouds, and they found 30 to 50 candidates that might actually be external galaxies. They went through and they narrowed them down to the top 10 or 12, and they chose 2 of them that had the highest probability of actually being galaxies. They didn't know, they couldn't see the stars in these galaxies. They could just see there was a blob of hydrogen there. And when they looked with Hubble, they found the 2 dwarf galaxies. And with Hubble being able to resolve the stars and being able to do the stellar populations of it, they were actually able to tell that these dwarf galaxies are late bloomers. They had a burst of star formation only 100 million years ago. All right, now I know 100 million years is really long to you and me, but in terms of the cosmos, that's 13.8 billion years old. 100 million years ago is way late in the universe to have such a burst of star formation. Okay, so these are galaxies that have been hanging out in what we call a void region of the universe. They're very, very slow developers. They're late developers, and only in the last 100 million years have they had a burst, a significant amount of star formation. Okay, so by using the radio to then follow up with optical, we can actually find these rare, small galaxies out in the universe. Okay. They're in the direction of Pisces. They're not in the local group. Okay, they're far enough away that they're outside the local group. Okay, all right.